Hey everyone, we are back with another question, which is kth smallest element in a binary search tree. So we are given here a binary search tree. As you see that the left side of the 8 is smaller than this and the right side node of 8 is larger values than 8. So what comes to your mind when you will be thinking of kth smallest element? For example, I have given a k as 4 and I get the output as 6. So you may be thinking, how would I get the output 6? So if you clearly look at here, the first smallest element is 1, the second one is 3, and the third one is 4, and the fourth one is 6. So 6 is our answer, which we'll be getting as an output. So what will be the brute force approach? So the brute force approach will be, you will be thinking is as in order traversal. Okay, so what in order gives is the sorted array, and then you will be storing it in the array. Let me write it. You will be doing an in order traversal. Apologies for my handwriting. You will be thinking of an in order traversal, and it will give you a sorted array, which will be as 1, 3, 4, 6, 7, 8, 10, 13, and 14. Okay, so you will be storing it into an array and you will be doing like accessing the V of 0 plus kth element, which will simply give you the minimum kth or the kth smallest element in the BST. But don't you think that it will be a bit complex than another approach? So here we will be having an extra space of V, which is simply of V of, here we will be having a space complexity of O of n, where n is number of nodes in the binary search tree. So can we done it in O of 1? Okay, let me think. Yes, we can done it in O of 1. So let us look at our approach, which I have written to you. So what we are doing here is we will be simply doing a DFS traversal. So yes, we are doing DFS traversal, which is similar to your in-order traversal you have seen above, but without any extra space or without any vector or an array. Okay, so let me run it. So first we are having an answer variable. Okay, and then I have a v. So now look at this function kth smallest tree node root int k. Okay, now what will be our root is 8. Okay, if our root is null, is our root null? No, it's not null, so we will not be returning -1. Now, v is initialized as k. So what our k here is, let me take k as again 4. Okay, so what will be our v become 4. Okay, now DFS of root. We will be calling this function DFS for our root. Now, if root is equal to null, is our root null? No. So we will be going for DFS root of left. Now, what is root? Roots left. We are now here. Okay, now again we will be calling this. So if root is equal to null, no, our root is not null. So we will be again going for roots left, which is 1. So now again, if root is equal to null, no. So DFS root of left, which is null. Okay, now if root is equal to null, yes, so we will be returning back here. Now what will happen is we are now here for root of 1. Now we will become v minus minus, which means it becomes 3. Okay, now if v is equal to 0, no, our v is not equal to 0. Now we will go for root of right, which is we are here. Now, if root is equal to null, yes, root of right is null, so we will be returning from there. So we return back here. And now it is completed as 1 has been traversed, so it will be returning back to 3. We will be pausing from here. Now, v minus minus. As we have traversed the left side of 3, now we will be v minus minus again. So it will become 2. Okay, now we will be moving to the, is 2 is equal to 0? No. Now roots right. We are now here. Okay. Now for left, DFS root of left. 6 left is 4. Okay. And then we will again doing for the left, which is null. So we will be returning from there. We return from here. And now v minus minus. We become 1. Now it will go for roots right, which is not again. So it will return back to here, and v will be minus minus to 0. V will be minus minus 0. If v equal to 0, yes, then answer is roots value, which is 6. Now DFS root of right. No, we will be now traversing the whole. So yes, now we will be come here and we will be returning answer as an output. So what will be our answer is 6. So this is a short video. So if you want to try with more example, then do it with a copy and pen and paper and do it by yourself by try running this approach and let me know about if you find anything difficult. So time complexity and space complexity, as you know that space complexity will be O of 1 and the time complexity will be O of n, as we have to traverse every node of the BST. So the space complexity, as you see that we haven't used any extra space like previous one, the vector. So this will be the TC and SC. So this is for this video. Hope you guys enjoyed. And please, please, please do it with your hand, and pen and copy and paper. Thank you.